Hi, hello. It's been a couple of weeks. I have started working on this Go for Engine, which is CPU rasterizer, which I am developing in Go language. I thought I would like to share some updates with you, what I have done so far. So let me close this engine window and let me walk you through my code. So what we are doing, basically, we have this main, so let me just actually walk you guys through the structure of this project. So we have asset, we have cores, we have fonts, we have GUI related model, we have look dev models where we have described our structs for color, material, texture, etc. Likewise, all our mathematics or logic is happening in the nomath library or the nomath module. All our testing OBJs are here in this folder. There are a couple of icons, pix maps. I'm using pictures. I'm using in this application, which are all here in sources folder. Tests, whatever I am. So currently I'm working on creating the assembly or asset, which is basically nothing but a self-contained asset, more similar to what we have in Unreal, where it bakes everything into a one single file. The shading data, the texture data, everything. We have all these textures which I'm using for my test. We have some utility function going on in toolsets.go, and then we have this widget which I have recently started working on. Uh, and we have our main.go here. So main.go, so basically it is running our main loop or a game loop. So how we are doing this? So don't bother about this populate scene function. What I'm doing is currently I don't have a proper asset manager or scene manager which I can basically use to populate my engine. So I have quickly wrote a populate function where it just importing bunch of assets and basically randomly placing them in my scene so that I can have something to play with. And I should actually stop the CPU profiling function because I don't really need those anymore. So what we are doing in main, we are creating a scene, and once we have created a scene, we are populating our asset to the scene. We are so we have used a default light, right, which is nothing but our sunlight. So I'm just placing this light at a particular location where my scene looks good. That's what we are doing, and then we are basically calling this window function, which is nothing but if we go there. So it's so what is window? So window basically we are using Raylib library in order to display our render output. And window is nothing but it's a main loop for the layering where we are initializing the window, we are initializing our other textures, we are creating a texture which we are going to display, we are creating our buffer, and then we are basically this is where our game loop starts, right? And then we are basically checking if our window is resized in order to change the render resolutions. We are handling the inputs events. We want our camera to be moved with our WASD keys and the mouse as well. So that this is where we are handling it. Uh, Recently, I am adding this app dot handle this site. So what I'm doing is we are basically creating. I am basically creating a proper Windows application, which will have menus, asset browser, scene hierarchy viewer, properties editor, etc., etc. So I'm just creating a layout, to build that. So that's what this app.layout is. And then we are basically rendering our scene. And all this stuff here you are seeing is basically the supplementary things which we do. We basically check the aspect and height ratios, etc., etc. We basically draw a debug test, we draw our trading status, we draw the keyboard overlays if we have, blah blah blah. Magic happens in this render function. So if we go to render is in scene. So if we go to this render, function, which is here. So what this render does? So it is obviously setting. So let me first actually run my app so that I can easily show you and make some relations with the GUI that what we are looking at and where it is actually coming from. So it is gonna take couple seconds. Yes. So here is our new GUI for the Gopher engine. If you press F2, it will open up the stats. If you press 3, it will basically start rendering on multi-thread, as you can see. So it basically gives you idea about how much scene triangles you have and how much it is rendering at each frame. So the number which you are looking at, which is constantly changing, and it's constantly changing because it is constantly evaluating those triangles. And we are actually loading something around 9800, 98,900. It's nearly 1 lakh polygons in this scenes. Uh, yeah. So basically, what it is doing is it is setting that triangle counter to 0. It is setting that drawn triangle counter to 0. It is updating a scene. Updating the scene means basically it is making sure that our camera is updated. What I mean by camera is updated is it basically make sure it's, if I go to camera update, it is making sure that our model matrix is updated, our postal planes are updated, etc., etc. And then it is going through each and every light and also making sure these lights are updated. It is going through all the assemblies and it is making sure all the assemblies are updated. Now, if you go to update assembly function, it actually what it does, it loops through all the geometries in the assembly and update that geometry, update the model matrix, update the view matrix, all the necessary things which we need to do. And then obviously before it starts render, one of the things which it does is it recalculates the lighting directions so that it can pass that lighting direction to renderer so that renderer do not need to calculate it each for each triangle. Now let's go back to render. So once it update the scene, it actually loops through all the lights and what it does is basically what it's doing is basically before it actually render out a diffuse pass, it actually renders out a shadow map. So this is the loop where it is basically it's using the threads and basically making this creating the shadow map, right? And once it does a shadow map, then it basically draws a view axis. Again, it basically creates a variable so that it can pass that variable to our render on thread or render on scene function. So if I go to render on scene, what it does is basically, as usual, it loops through all the assemblies, loops through all the geometries, gets its model matrix, MVB matrix, normal matrix, loops through all the triangles and basically check for the back culling stuff, check for if it is behind the camera, etc., etc., calculate the normals and everything, and then finally passing it to our render, uh, render triangle function over here. So if I go to render triangle function, what render triangle function does is actually again, it is looking messy because it is messy actually. I am yet to clean up the code, but it is what it is showing is basically it is determining where that triangle is in the scene with respect to camera and then passing it to the rasterized triangle function. Rasterized triangle function, what it does is again determine the normal, determine the angles, etc., etc., and then finally pass it to the our lighting function. And lighting function, as you know, if the texture is available, it samples the texture. It basically takes the diffuse from the normal. It checks what the specular, if there is any specular normal map available, calculates all that stuff, and finally return basically RGBA buffer to our rendered image. And this is how it is working. There are a lot of functions, obviously helper function which we are doing. Like if you come to render basically can there is a resize function which actually handles the resize. There is a clear function on every frame we are rendering. For every frame we are rendering, it is clearing our render buffer, and then we have functionalities to basically save our render into a PNG file, and then we have basically once no, so since we are not actually writing an image, we are actually creating a RGB buffer. So we basically convert that buffer which Raylib can understand, and that is what this function is doing to image, and then Raylib displays this image, right? And then we have this helper function where we are basically drawing the 2D, 3D images if you want, right? So if I open this, now you can see this is how our development, I mean, this is how our progress looks like. Now I have loaded the streets. Again, these are not instances, these are all polygons. And you can see there are a couple of towers I have added randomly in the scene just to check how it is working. Uh, I am actually using the WASD keys to move around the scene, and then I am using my mouse as well to basically turn the camera. Sorry about that. Uh, right now, what I'm working on is basically creating this GUI. Right, so what I have done is I have created these panels, Scene Explorer, Render View, Attributes, which is nothing but a property panel, and then we will have our asset browser where we will be actually interacting with the assets, scene assets which we have. Or we can basically create a new asset, blah blah blah, and we have a menu bar as well. I was, and as you can see, if I drag this little triangle left to right, it is actually scaling the widgets, which is helpful if, let's say, I want to see more attributes from my property editor. I can just squeeze the sides or shift it on a left side so that I can see the attributes, or I can basically increase the size of my asset browser if I have too many assets, just to check, right? Uh, Obviously, I'm not populating any of those widgets here because I am yet to write that functionality. But yeah, this is how it is working. I know the FPS is low, but it is not an optimized version. I am targeting for 50 to 60 FPS, or at least a million. If I can crunch, or if I can get a 40-50 FPS for 1 million triangle count, I think it will be worth uh, you know expanding this into a gaming engine rather than just a CPU rasterizer. Uh, so for UI, for the GUI layout, what I have done is here is our layout.go. So what we have here is we have basically a panel and the layout. So what you are seeing is this Scene Explorer is a panel, render view is a panel, attributes, see, asset browser is a panel, and those all panels are basically come together into this layout where we have basically uh, store them, and it basically then handles the update function, handle how it should draw the panels, handle how the resize and how to resize the panels when someone basically drag those resize handles, and then we are drawing and all the things together. There is one interesting function we have in our engine window. Where is our engine window here? Okay. So I was explaining about this handle inputs event. So what it actually does is if I go to this function, it actually, these are the Raylib events, right? So if the window is not focus, then we are not doing anything. We are basically just ignoring those keyboard inputs. If we found out that someone pressed the F key, then we are basically uh, changing the resolution scale. Again, this functionality is I have disabled this functionality, but yeah, if someone presses F2, then we are displaying the debug screen. So if I press F2 again, then it will disappear if I. So it's basically a toggle. Okay, and then we are basically moving. We are basically handling this W as AD keys for our uh, camera movement, right? Keyboard interaction. I have some mouse event as well, where if I can right click and drag, then my camera turns around its y-axis, and then I have something called panning. If I basically press middle mouse and drag, my viewport pans. Although it is very slower, but yeah, it's there. The functionality is there. It is basically different. So like and if I right click and drag, it actually rotates, and I can basically look around in the scene. Cool. So these are my updates from the latest build. Currently, the I'm working on this Qt integration branch. Although the name is not right, I actually wanted to use Qt to build the interface or the GUI, but there is I'm much familiar in Qt than Raylib, but there is a problem with Qt integration with Go. It is not really fully functional. I have faced so many problems while creating just a single, simpler widgets in Go. So that's why I dropped to use Qt and continue with Raylib. All right, these are all my updates. I hope you like this video. You learned from this video. Please share, subscribe, and like this video. Bye bye.